In this clip, I'm going to talk about refactoring. Refactoring is about changing existing code with the aim to improve it. This can be horrible code written by your colleagues or by yourself a while ago because you gained new insights that you want to apply to improve the existing code. Until now, we've mostly considered the situation where you start designing software from scratch. In practice, you will work with existing systems most of the time. So, does this mean that design patterns are useless then? Well, no. You can still apply these design patterns to existing software. Perhaps you want to improve the internal structure. You want to make the code easier to test. You're thinking about adding new features, and that means you need to restructure some of the concepts in the code. Martin Fowler, a well-known software engineer, has written a book about refactoring. He defines it as a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. The idea of refactoring is not to add new features to your code, but to revise the original structure with the aim to improve it in some way. Let's look at an example where we can apply the idea of refactoring. This example comes from the first chapter of Fowler's book. Initially, it's not that well designed, and we're going to refactor it step by step to improve the design. So here's the starting situation in a UML class diagram. A movie is represented by an object that has a title and a price code, which differentiates between children's, regular, and new movies. Each movie rental is represented by a rental object that keeps track of how many days the movie is rented. The rental object has a movie object. Finally, we have a customer who can rent several movies. Here's the code that computes the total price paid by the customer and the point that the customer has earned. What's the problem here? This fragment of code has two responsibilities: computing the total price and the number of points. This means the code has weak cohesion. It does too many things. To fix this, let's introduce a separate method for dealing with the details of computing the rental prices. And this is what we get. We created a method called calculatePrice that calculates the price for each rental. Now the code is already a lot cleaner, but it would be better if we also separate the task of calculating the earned points for a movie. And now we get this. We introduce another method, calculateEarnedPoints, that does the point calculation job for us. It uses the current point total and the rental to compute the new earned points total. But now we see that the vPrice variable is actually not needed anymore. So we can simplify this code even more. This looks a lot better. Now you can ask yourself, does it actually make sense to do these two unrelated computations in a single loop? Possibly this comes from old school programmer habits to over-optimize code. Let's save 0.02 milliseconds of processing time at the expense of losing cohesion. From a design point of view, wouldn't it be better to define separate methods for computing the total charge and the earned points total? You can guess the answer to that question. In the previous example, we saw two types of refactorings: extracting code into a separate method and removing a temporary variable that's no longer needed, vPrice. Another reason you might want to refactor code is to introduce a design pattern. For example, here we have a complicated if-else statement which is difficult to maintain. Applying a design pattern can solve this problem. In this case, you can use a strategy pattern to separate the choice of the algorithm from the implementation of the algorithm. If you have to select between a couple of different choices and depending on that computes something different, it's an indication you should apply the strategy pattern. It's easy to introduce bugs while you're refactoring, and big refactors, such as introducing design patterns to replace a bunch of tightly coupled, weakly cohesive code, can lead to problems. So what's the best way to refactor? First, don't start refactoring complex code unless you have a way to test it. Otherwise, there's no way for you to verify that the program's behavior stays the same. You want to refactor in small steps so that you can then test each of these steps and verify more easily that you didn't introduce bugs. You also need a possibility to go back to the pre-refactored situation. In some cases, you discover during the refactoring process that your refactoring isn't possible after all, because you overlooked something. You need to be able to go back to the previous version easily in this case. And finally, test your program after each refactoring step to make sure you catch bugs as early as possible. There can be many reasons why you need to refactor. You may want to improve your software's overall design by eliminating duplicate code. You might want to make your software easier to understand for other developers, easier to adapt to upcoming features, or easier to test to improve overall stability. You might want to refactor to standardize parts of your code using design patterns. This also helps spotting bugs. Overall, refactoring over the long term helps you develop faster. There's a so-called rule of 3 for refactoring. The first time, don't think about it too much, just write the code. The second time, you notice you start writing duplicate code, and being a good software designer, that annoys you. Then, the third time, you refactor. Try to incorporate refactoring in your general development process. When you add a new feature, fix a bug, do a code review, just take a closer look at the code and do some refactoring as well to reduce coupling and increase cohesion. Next to talking about refactoring, Fowler also identifies what he calls bad code smells. These are not bugs, but they are symptoms of a problem in your source code that indicates bad design or the need of a refactoring somewhere. By keeping such a list of bad code smells in the back of your mind, you can more easily spot them when you're looking at code or while you are developing. This way, you can solve them before they lead to bigger problems. Let's look at a few examples of bad code smells. Take a look at this code. What's the bad code smell here? It's duplication. The code to convert Fahrenheit to Celsius is copied 3 times. And what's the remedy? Introduce a method. Sometimes you have a really long method in your code that does a lot of things. In some cases, the name of the method already indicates there's a problem with cohesion, like here. In other words, the method is doing too much. To solve this, split the code into smaller, more cohesive methods. Or how about this example? The infamous utils class. The name is vague and indicates that this class is doing too much. The remedy? Split the class into smaller, more cohesive and loosely coupled classes. Here's another type of bad code smell. This method has way too many parameters. This usually means that a method is doing too much. It has weak cohesion. The remedy, again, is to split the method into smaller, more cohesive methods. Another bad code smell, but this time more on the design level. Suppose that you want to make a change to your code. For example, you want to introduce a new kind of movie in the video rental case study. In order to do this, you find out that you need to update the existing software in many different places. This is called shotgun surgery. If it happens a lot, your software is poorly designed. When you develop software, your code is going to change and be extended over time. Features and extensions you didn't consider in the beginning are added to your code in the future, and your original design might not work anymore. For example, in the shape software, you might want to add extra features such as colors, color management, border types, reflective properties, normal maps, and so on. As a result, an individual shape object will become less cohesive. You probably have to introduce separate classes for this and use something like the strategy pattern to establish how these concepts are related. Another bad smell, and we've seen this one before. What's wrong here? The responsibility for the computation is in the wrong place. The remedy is to put this in a separate method, or introduce a strategy pattern for dealing with the different price calculations. And what about comments in your code? You'd expect comments to be a good thing, since they help explain what code is doing. It should be a sweet smell, not a bad smell. The problem is that ideally the design, choice of names for variables, methods, classes should be as clear as possible. If you need a lot of comments to explain what a piece of code is doing, that's probably a design or a naming issue, or both. If you see something like this, it's a great candidate for refactoring. A specific example of bad naming is using excessively long names for things. If you tend to use names that are too long, there might be something wrong in your software architecture that leads you to resort to long names to explain what the variable is for. The example here is from a class of the Java Swing library. Too short variable names are also problematic. A variable name should explain what it's for, so you more easily can follow in the code what is happening. Also, try to avoid using literal values like 3.14 in too many different places. Introduce a constant like pi for them. Or even better, just use the pi constant from the Python math library. In Fowler's book, each refactoring is described using a unified format. A name and a summary of what the refactoring does. A motivation of when to apply it. He also gives an overall mechanic of how to apply the refactoring. And finally, he gives examples that illustrate how the refactoring works. We're going to briefly look at a few common refactories from his book. The first one is called INLINE TEMP. The INLINE TEMP refactoring is useful if you have a temporary variable somewhere and it's no longer needed or gets in the way of other code changes. INLINE TEMP replaces the references to the temporary variable with the expression. For example, suppose a function returns whether a given price is higher than 1,000. But the base price variable is used only in one place. You can then inline the temp by replacing it with the actual value. Overall, this is what the mechanics of inline temp look like. First, you declare it as a constant and check that it's only assigned once. Note that in Python, this step is not possible because Python doesn't have constants. Most other languages do, however. Then, you find and replace all references to the variable with the right-hand side of the assignment. Test your code after each change to make sure everything still works. Finally, remove the temporary variable altogether and test the program once more. In most cases, temporary variables are not a problem in your code, so you don't have to remove them. But sometimes they get in the way of other changes you want to make. So that's the moment you want to apply the inline temp refactoring. Most of the refactorings in Fowler's book also have an inverse. For example, the introduce explaining variable is the opposite of inline temp. This refactoring introduces extra variables as opposed to removing them, as you can see in this example. Here, the extra variables help explain what we're actually computing. In the initial version, I added a comment to explain this. In the refactored version, the comment is no longer needed because the variable names already explain this themselves. Nowadays, you don't have to do all these refactorings by hand anymore. Most software development environments, such as Visual Code or Visual Studio, support automatic refactoring that do a lot of the work for you. You still need to test your code though to make sure the refactoring didn't break anything. Now, before I finish this clip, let's look at a few more refactorings. These refactorings are more on the level of design. The first one is introduce parameter object. If a method has many parameters, it's difficult to call because you need to supply so much information. You can group parameters that belong together in an object to address this. If you have a process customer on date method with lots of parameters related to both dates and customers, you can reorganize it into date related parameters and customer related parameters, leading to two objects that store that data. This considerably simplifies the method header. Sometimes you need to move code to increase cohesion. Here's an example of a person class with quite a lot of attributes. With the extract class refactoring, you take a part of those attributes and store them in a new class. Here we introduce a new class address that contains the address data of the person, and address becomes a single attribute in the person class. If all subclasses have a discount method, perhaps it should be defined in the superclass instead. This is called the pull-up refactoring, and it helps you reduce duplicate code. The inverse is also possible. If the superclass contains a drink method, but it's not used in all of the subclasses, perhaps it's not in the right location. Why should we need to provide a dummy implementation of drink in the Apple class? So, you apply the pull-down refactoring to move the drink method from the superclass to the subclass that actually needs it. There are lots of other refactorings possible. You can extract a common superclass when classes share similar attributes and methods. Obviously, only do this if those classes are related in some way. You can introduce a new subclass of an existing class, and there are many more. So overall, refactoring keeps your code clean. Try to write code that documents itself. Choose meaningful names, keep methods cohesive, and keep the overall control flow simple by introducing design patterns when needed to provide structure. When you refactor, do it in small steps and test after each step to make sure you didn't break anything. We've reached the end of the refactoring clip. If you have any questions, post them in the Teams channel of the course. Thanks for watching, and catch you in the next one.